and ready to listen the class. Listen, in the last class we have learned about we have started with new unit called atomic structure, and we have learned about the Dalton's atomic theory and about the discharge tube. For what we use this discharge tube and the conclusion, that the two results of that discharge tube. In today's class you are going to see atom. When you consider atom, we have seen that it is the smallest particle, and whether you think that atom has some other particles inside. Actually, seeing atom has electrons, protons and neutrons. This protons and neutrons are in the nucleus, in the center. When you consider an atom, it has a nucleus in the center and electrons revolve around this in various shells, that you will learn later. This nucleus will be having protons and neutrons, and electrons will revolve around this nucleus. This is the general structure of an atom. So now we know that atoms has electrons, neutrons and protons. Now how can we know that if protons are there, electrons are there and neutrons are there? For that we have a series of experiments. We can see one by one. The first one is discovery of electrons. J.J. Thomson in 1897 have discovered the electrons. How he have discovered means, he has passed this see here, this is two plates are here, no, this is deflecting plate, parallel deflecting plate. It is flipped parallel. So he allowed cathode rays, this is nothing but cathode rays. He allowed cathode rays to flow through between this deflecting plates. What happens to this cathode rays means, it will be turned towards the positive plate. This cathode rays will turn towards the positive plate of this sector. So if here it is positive, the coming ray is negative. So the opposite charges attracts, right? Why it is attracted towards the positive plate? It is negative charge. So from that we have concluded some particles are present in the cathode. That particles are attracted towards positive plate. Some particles are present in cathode. Only if there is some particles, it will get attracted, right? So it is attracted towards the positive plate, and he named that as corpuscles. Later it is called as electrons. He has concluded that cathode ray has some particles that is attracted towards the positive plate. So as positive is attracting, it should be negative. The particle coming is negative, and he named that particles as corpuscles or electrons. Clear? I repeat, listen. The cathode rays are, this is cathode and this is anode. The cathode rays are allowed to pass through parallel plates of opposite charge. One will be positive and one will be negative. When this cathode rays pass, it is attracted towards the positive plate. So he named that particular particles coming with cathode rays as corpuscles, and later it is called electrons. Clear? Come to the next one. Discovery of nucleus. Next one is to prove that there is nucleus. Rutherford in 1911 he has conducted some experiment. Actually this experiment was conducted by Hans Gale and Ernest Marsden in the guidance of Rutherford. Rutherford guided these two persons, and they both conducted the experiment on a gold foil. Consider this is a source. This source, what it does is it gives some alpha particles. These alpha particles are allowed to pass through this thin gold foil. This gold foil will be too thin. This alpha particles are allowed to pass through this thin gold foil. What happens to this alpha rays when it passes through this gold foil means, actually this gold foil is kept inside in a setup which is made up of zinc sulfide fluorescent screen. The screen around this gold foil, that is this screen, is made of zinc sulfide, it is called zinc sulfide fluorescent screen. When this alpha particles strike this gold foil, see here, see this diagram. Consider these are the alpha particles. This is the gold foil. Some of the alpha rays travel to the next side through this gold foil. It indicates that many of the particles will travel to the next side without any disturbance. It shows that maximum of space in atom is free, empty, and some of the particles, see this example, it touched this nucleus and deflected. It is deflected to some angles, little deflection. So it shows that some positive charges inside the atom and some of the rays are rebounded. The rays actually hitting this nucleus, this thick nucleus, thick and hard nucleus, the rays, alpha particles striking to this nucleus will be rebounded. It will hit that and come back. It is rebounded. So he has concluded that maximum, most of the, now I will draw this separately. So when you consider this as an atom, when the ray is passing from this side and receiving that side, it shows that in maximum places, when it is going here, except this place, when it is passing through other places, it is coming to the next side. So maximum place in the atom is empty, and when it is striking in this border of this nucleus, it will get deflected to some angles. So we can say some positive charge particles are there, and when it is clearly hitting this nucleus, it will be rebounded. It shows that there is nucleus in the atom. Clear? This is why he concluded that there is nucleus in the atom. So far we have learnt there is electrons and there is nucleus. Still we have two. We have protons and neutrons in the atom that we can learn next. Next one is about discovery of protons. In discovery of protons, in 1887, Goldstein has performed some experiments and found that anode rays are present. Anode means positive. The positive rays are present. You see this simple experiment. This is cathode. This is anode. When you give high voltage, this is a vacuum pump. When you create vacuum in this tube using vacuum pump, and when you apply high voltage to this setup, this is same as the discharge tube, right? You have to apply to cathode and anode the supply. When you apply this high voltage, automatically from this anode rays will come out. But he was unable to find some conclusion from this experiment. After this, in 1897 only Thomson discovered the electrons. So when this Thomson discovered electrons, there is a situation arrived that if there is electron, that is negative charge, there should be positive charge also. So only when you have negative and positive, it will be neutral. So that after the discovery of electrons, they came to a conclusion that there will be some positive charge also. Then Rutherford started with this idea. Rutherford started having several experiments. He found that any particle, when you bombard with alpha particles, hydrogen atom is emitted. That is, when you bombard any particles, that is electron or protons with this alpha particles, you have to take any particle and you have to allow alpha particles to strike on that. He found that hydrogen atom is emitted and the positive charge of that atom is hydrogen nuclei. He found that the positive charge in that particular thing is hydrogen nuclei. Then he named that hydrogen nuclei as protons. Clear? What he found? He found that if you bombard any particles with, bombard means allowing it to strike fastly. When you throw this chalk on my hand, I am bombarding my hand with this chalk, right? So there should be a speed. So when you bombard any particles with alpha particles, he found hydrogen is emitted and he found that the particular particle has positive charge and that is hydrogen nuclei. Then he named that hydrogen nuclei as proton. So proton is which charge? Positive charge. Thus he found the existence of protons. Clear? Next one is discovery of neutrons. You have learned about protons, electrons, nucleus and the last one is neutrons. Till the end of the beginning of the 20th century, all thought that only electrons and protons are there in an atom and thus entire mass of that particular atom is contributed by the nucleus. When you consider this, the mass of the atom is in the nucleus. These electrons have negligible mass and it is very light. And the entire mass is there in this nucleus. That was the conclusion from Rutherford's gold foil experiment. And next what happened means, on further going on with many experiments, they found that the mass of this nucleus is double the mass of protons. This nucleus has protons, but its mass is 2 into protons, that is nucleus. Now you know proton, but you have to know the remaining. This clearly says that, for example, if a nucleus is 10 gram, 5 gram proton, whereas remaining 5 gram. So it showed, further experiments showed that some other subatomic particles are also present in the nucleus. And in 1930, Frederick and Irene Joliot Curie, these two scientists, they have performed an experiment. What they have done is, they have taken a paraffin, this is paraffin, they have they have taken, this is beryllium, they have bombarded this beryllium with some source, that is radium. This is the polonium source, that may be polonium. When they bombard this beryllium using this source, what happens means, and they allow this to pass through the paraffin. When it passes through the paraffins, the output is, we get neutrons. When we bombard this beryllium with this, you have to, from this source, radium comes out and this beryllium is bombarded using this beryllium. This beryllium, when it is bombarded using this source, neutrons are given out. But they have found neutrons are there. Later on in 1932, James Chadwick, he have found that, he have done some experiments and said that the neutrons are present but they have no charge. They are neutral. Already they are neutral and it has mass and it has no charge. So finally electrons are negative charge, protons are positive charge and neutrons they have found it is neutral. It has no charge but it has mass. So when you consider the nucleus 10 gram, the nucleus is 10 gram means this 5 gram is protons and the remaining 5 gram is neutrons. Finally James Chadwick said that the neutrons are also present in the nucleus but it has no charge. It is neutral. So we have learned about the discovery of electrons. Then discovery of protons, then nucleus, finally neutrons. I hope you all understood about today's class. In the next class we can learn about, before we went, we have in your book you have a tabular column, basic characteristics of subatomic particles. That is electrons, how we represent electrons, E minus. Then protons, how we represent P plus because it is positive charge. The neutrons, how you represent? Neutron has no charge. It is neutral. Then the next column, change, charge, their charge, how much the charge it holds. It is given in coulombs. For electron, minus 1.6 into 10 to the power minus 90 and protons 1.6 into 10 to the power minus 90 and for neutrons it has no charge, so we cannot give charge for that. Then in mass, the mass of electron is 9.1 into 10 to the power minus 28. Mass of proton is 1.6 into 10 to the power minus 24 and the mass of neutron will be same as that of mass of proton because nucleus you have proton and neutron both has equal masses as I have given in this example. So that's all for today. In the next class we can see about atomic model. I hope you all understood today's class. We can meet in the next class. Thank you.